Hi, this is Lab 4, bar magnets. My introduction. In this lab, we analyze the magnetic field produced by a permanent bar magnet. We focus on how the field strength changed with the distance from the magnet. Using a magnetometer, we measure the magnetic field components in different orientations and positions relative to the magnet that allowed us to verify our theoretical predictions about the magnetic dipole field. The purpose of this lab was to measure the magnetic field strengths of a bar magnet at various distances to become familiar with the relationship between distance and the magnetic field due to a bar magnet. Here are some key concepts. Magnetic dipole fields. A bar magnet can be used as a magnetic dipole. Magnetic fields produced by the dipole varies with distance according to the on-axis power law and the off-axis power law. The on-axis power law points along the axis of the magnetic dipole. The magnetic field decreases with distance, according to this formula. The off-axis power law says that it still varies with an inverse cube distance, like the on-axis power law, but the direction depends on the angle from the dipole axis, according to the formula below. Another key concept is the logarithmic analysis that we used. To determine the power law relationship, we use the formula natural log of the magnitude of magnetic fields is equal to the natural log of k dot product of n dot product of, it's supposed to say the natural log of r as well, where n is the slope and natural log k is the y-intercept. The Earth's magnetic field compensation. We needed to account for Earth's magnetic field. By setting up the experiment so that the Earth's magnetic field was orthogonal to the magnetic field, we were able to isolate the bar magnet's contribution. The experiment itself. The systems and surroundings. The bar magnet, which was the source of the magnetic fields, and the Earth's magnetic field. Our steps. We placed the magnet on one end of the meter stick and positioned the phone perpendicularly where the absolute value of x was at a maximum, and the absolute value of y was at a minimum. We rotated the phone 90 degrees and repeated to find the second line. We then placed the phone at an intersection of these lines. We placed the magnet aligned with one end and the phone on the opposite end to find the distance where the x-component, the magnitude of the magnetic field for x is equal to 20 UT. We repeated this 3 times and then at several different field strengths. Then using the spreadsheet, we created a plot of the data that gave us the slope n and the y-intercept natural log k. From the y-intercept of the plot, we can calculate the magnetic moment of u in the bar using this formula. Possible sources of error. For an ideal magnetic dipole, we're looking for n is equal to -3. Any deviation of this could be the result of non-ideal behavior or measurement errors. It could also be the result of any nearby electrical equipment or metal objects that can distort the magnetic field. The local environment as well, like any steel or electrical wiring in the walls or the chairs or the table. Here's my code. And here are my results. In conclusion, the question was given, which of these statements describes what we observed? We observed 4 and 1. For 4, as the magnetometer moves closer to the magnet, the measured x component in the magnetic field increases. This is because, according to the inverse power law relationship, as distance decreases, the field strength increases. Also, we experience number 1 because of the inverse cube law, where b is proportional to 1 over r squared, or r cubed. So the field becomes very weak and approaches 0 as the distance increases.